This lecture will cover the data type dictionaries in Python, how to create them, and how to use built-in functions for dictionaries in order to use them within your program. Dictionaries is one of the standard Python data types. Dictionaries are different from the data types you have learnt about so far. Strings, lists, and tuples are sequential collections where the items can be accessed using indices. In dictionaries, the items cannot be accessed using indices. Dictionaries are unordered, associative collections with mapping from key to a value. Dictionaries are used to store any two kinds of information that match up. For example, in this slide, a dictionary is visualized by the blue sphere on the right side. The dictionary contains 3 items, which can be accessed with the key's size, age, and color. For each of these keys, a value is attached to it. For the key size, the integer value 3 is stored. For the key age, the integer value 67. And for the key color, the string value white. This slide also shows how a dictionary is structured, with the keys and values indicated. Another example is also shown, which exemplifies how we can use dictionaries to map between nucleotides and amino acids. In the second example, the keys are different codons, that is, triplets of nucleotides. One specific combination of 3 nucleotides refers to one specific amino acid, and the amino acid is the value attached to one key. The order of the key-value pairs in a dictionary does not matter. In order to access the values in a dictionary, you have to use the keys and not an index. A dictionary is enclosed with curly brackets and with key-value pairs added as key-colon value between the brackets. Only immutable objects such as strings, tuples, and numbers can be used as keys. Immutable objects cannot be changed after they are created. Mutable objects, such as lists, dictionaries, and sets, cannot be used as keys. A dictionary can be created in several ways. An empty dictionary is created with a pair of curly brackets with no key-value pairs between. Key-value pairs can then be added by 3 different ways. The pairs can either be added one by one to the dictionary, or all of them at once, by adding key-value pairs between the curly brackets or by using a sequence, for example, a list in combination with using the dictionary function dict. The example on this slide shows how to create an empty dictionary, simply by assigning the variable to curly brackets. The variable data is now of data type dictionary and holds no items. In the example on this slide, first an empty dictionary is created, called data, and thereafter key-value pairs are added by mapping between codons and amino acids. The codons are the keys and written after the variable name and between square brackets. The amino acids are the values and each assigned to a specific key in the dictionary. To note, the key is written between square brackets after it has been created and not between curly brackets. In this way of filling a dictionary, the curly brackets are only used when it is created. Thereafter, square brackets are used when assigning and accessing the keys. A dictionary can also be created with all key-value pairs at once. The key-value pairs are added within the curly brackets by first writing the name of the key, followed by a colon, and then the value that should be matched with the key. Each key-value pair is separated by a comma in the dictionary. A dictionary can be created from a sequence, for example using a list in combination with using the dictionary function dict. For implementing this, a list of lists is first needed to be implemented. In this example, the variable nn2 AA_list is assigned a list of lists. The list consists of a number of inner lists, and each inner list consists of a key-value pair. In this example, the list consists of 4 inner lists, each a codon as key and matching an amino acid as value. Thereafter, that is, statement 2, the list is sent as an argument to the function dict. This function converts the list of lists to a dictionary with key-value pairs. The return from dict is a dictionary, and in this example assigned to the variable data. Since the order of the key-value pairs does not matter, we cannot access the values using an index. Instead, a value in a dictionary needs to be accessed using the key. For example, the value of the key AUG in the dictionary is accessed by writing the key name between square brackets, after the variable name, and thereafter the matching value is assigned to the variable AA. A new key-value pair can easily be added to a dictionary. For example, mapping between the key AUU to leucine, that is LEU, in the dictionary is added by assigning the value to the key. The key AUU does not exist in the dictionary from the beginning, but with the assignment, the key-value pair will be added. In similar, a value for a key can be changed by assigning a new value to that key. A key-value pair can be removed by using the Python keyword del, as exemplified in this slide. One needs to state which key in the dictionary that should be removed. If the key does not exist in the dictionary, it will raise a key error message. Just as lists, dictionaries have many built-in methods. This slide outlines some useful dictionary methods. We will now take a look at some of them. It is possible to extract all keys in a dictionary by using the method keys. In this example, first the dictionary data is created and assigned a number of key-value pairs. Thereafter comes a print statement where the keys from the dictionary is printed out. The method is called by adding a dot to the variable name, and thereafter the name of the method. In the same way as with keys method, we can use the values method to extract all values stored in a dictionary. In this example, the same dictionary is first created, and, within the print statement, the values method is called upon for the dictionary. We can iterate over the keys, values, and items of a dictionary. We will first take a look at how to iterate over the keys in the dictionary. For this, it is not necessary to use the keys method, since this is done implicitly by iterating over the dictionary. Take a look at the example in this slide. First, the dictionary variable data is created. Thereafter, we implement a for loop and iterate over each key in the data dictionary. For each key, we make a print statement and print out the key. Hence, in each iteration, the key is stored in the variable named key. We can use any name of this variable. For example, name it codon instead, if we want to. To iterate over the values, we need to use the method values for dictionaries. In this example, the same dictionary is created and stored in the variable data. Thereafter, we implement a for loop to iterate over the dictionary. Here, the for condition is extended by calling on the values method on the variable data. Hence, to the variable name we add a method call. This will return the values in the dictionary one by one. For each iteration, the value is stored in the variable value, which is thereafter printed out by the print statement within the for loop. The method items returns key-value pairs. In this example, the method items is called upon for the data variable, and in each iteration, both the key and the value is returned. Hence, for the method we need two variables in the for condition to handle both return values. The first value returned is the key and stored in the key variable, and the second is the matched value, which is stored in the value variable. The two return variables are separated with comma in between. The key and value variables can thereafter be used within the for loop. For example, printed out by using a print statement. In Python, there is a difference between an alias and a copy of a variable, which is important to remember. Aliasing is when two variables refer to the same object, meaning that changes to one affect the other. If you assign a dictionary variable to a new variable, then an alias is created of your dictionary. This is important to know since you can easily overwrite your dictionary without intending to. To make a separate copy of a dictionary, you must instead use the method copy. By using copy, you will not overwrite the initial dictionary. In this example, the variable data underscore alias is assigned the variable data. This will create an alias of the data variable. Changing the value for one key in the new variable data underscore alias will change the value for the same key in the original dictionary data. In this example, the variable data underscore copy is assigned the copy of the variable data. This is done by calling upon the method copy on the variable data. In this case, changing the value of one key in the variable data underscore copy will not change the value for the same key in the variable data